Hello everyone, how are you all? I hope that all of you are doing amazingly great. First of all, welcome to this session. So we are on lecture number 1 of solution of triangle. In this session today, we will be learning about some important theorems and important formula about sine rule, about cosine rule, and their application we'll be seeing in this session. So basically, what is solution of triangle? It means that finding things about triangle. There are 6 important things in a triangle, 6 important things. What are those 6 things? 3 sides and 3 angles. So getting information about them. Suppose side is given, angle is given, you have to find out rest of the things. So there will be using some different formulas and we'll be looking at their derivation. So we'll go from basic and let's see what types of question we are going to see in this chapter. So let's get started with this chapter. So what are we going to study in this session? In this session, we'll be learning about sine rule and cosine rule. And if we have time, we'll learn about more rules after this. So let's get started. So in this topics, first of all, let's get started with sine rule. So sine rule says that in any triangle ABC, sine of angle A divided by side A is equal to sine of angle B divided by side B is equal to sine of angle C divided by sine C, and that is equal to 1 upon 2r. This is what sine rule says. Okay. Sine A upon A is equal to sine B upon B is equal to sine C upon C, that is equal to 1 upon 2r. This is about sine rule. We can easily prove that as well. That in any triangle, in triangle ABC, okay, there is a circumcircle to this triangle. There must be some circumcircle to this triangle. Okay, the center of this circumcircle. Let's say that this is the center of the circumcircle. If this is angle A, at the center, it will make angle 2A. Correct? Basic property of circle. This chord BC is making angle A at the circumference, so this is going to make angle 2A at the center of this circle, right? And this opposite side is, the side opposite to vertex A is known as small a. Okay, everybody. So, in this triangle, this is 2R, correct? This is 2R. This is R. This is R, which is known as circumradius of this circle. So this is circumradius, this is angle 2A, this is side A. If I drop a perpendicular from the center, so perpendicular will divide this chord into 2 equal parts. So this part will be A by 2, correct? Now in this triangle, this will be angle A. So in this triangle, if you look for sine of A is equal to what? Sine of A is equal to side opposite to that angle, which is A by 2, upon the hypotenuse. Hypotenuse is capital R. So from here we can see that sine A upon A is equal to 1 upon 2R. So this is what we are getting, that sine A upon A is equal to 1 upon 2R. In the similar way, we can see from this triangle, just some simple geometry. In this triangle, again drop a perpendicular to opposite side. This will be B by 2, this is angle B, and now from this triangle, see about sine of B. Okay. So from this triangle, you will get the same relation, that sine of B upon B, that is also equal to 1 upon 2R. In the similar way, sine of C upon C is also equal to 1 upon 2R. So this is the derivation behind our famous sine rule. Okay. Now we'll be using this rule in some of the questions. Some of the students remember this rule like this, that A by sine A upon sine A is equal to B upon sine B is equal to C upon sine C is equal to 2R. This is also one of the famous way to remember this rule, that A upon sine A, where A is the side A and capital A is the angle A. Okay, where ABC, small ABC are the sides, capital ABC are the angles. So A upon sine A is equal to B upon sine B is equal to C upon sine C is equal to 2R. Are we clear? Now, Few important identities that you must have learned in the previous chapter in trigonometry that we will be using again in this chapter. So have a look at these identities, that sine of a plus b is into sine of a minus b, that is equal to sine square a minus sine square b. Or if sine square a minus sine square b is written, we can write this thing as sine of a plus b into sine of a minus b. Okay, very important identity. We'll be using this identity in this chapter several number of times. Now another identity, that sine of b plus c is equal to sine of a in any triangle ABC. Okay, simply just replace b plus c with pi minus a. Simply just replace b plus c with pi minus a, because we know that a plus b plus c, sum of all the three angles in a triangle is pi. So you can write b plus c as pi minus a, and sine of pi minus a will be sine of a. Okay, so we can write sine of b plus c as sine of a, and if sine of a plus c is written, we can write it as sine of b, because these are what? Supplementary angles. We can write a plus c as pi minus b. So sine of pi minus b will be equal to what? That will be equal to sine of b, correct? In the similar way, if there is like cos of a plus b, now I am going to write this as minus cos c. Minus sign will be there. Why? Because cos of supplementary angles are negative of each other. If you write here a plus b as pi minus c, just simply replace a plus b as pi minus c. So we have cos of pi minus c, and cos of pi minus c is equal to what? Minus cos c. Okay, very simple, very easy. Moving ahead. Now let's do these important and standard equation. These are what? Hashtag standard equation. You will find these equations in all your books, in all your standard books. These are some of the standard equations. So a times sine of b minus c, b times sine of c minus a, c times sine of a minus b. We have to prove that the sum is equal to 0. So let's use sine rule over here. We will be using sine rule whenever we want to write side in terms of angles or angles in terms of side. So at that time we use sine rule. So here side A is written, side B is written, side C is written. I am going to write these sides in terms of their angles. Now recall the sine rule. Sine rule says that A upon sine A is equal to B upon sine B is equal to C upon sine C is equal to 2R. Okay, 2 times the circumradius. This is the sine rule. Okay, now you can consider 2R as some constant k as well. So I can write A as k sine A, B as k sine B, C as k sine C. So that's the idea. I'm going to write this side A as k times sine of A. Then we have sine of B minus C in the multiplication. I can write side B as sine C times k, means k times sine C, k times sine B, and sine of C minus A is written in the multiplication. I can write this side C as k times sine of C, k times sine of C, and sine of A minus B is written over here. Okay. So I converted these sides in terms of the angle. Now I can write sine of A as sine of B plus C. So it is k times, you can take k common from all of them. If you take k common, here I can write sine of A as sine of B plus C, right? Because sine of B plus C and sine of A will be equal because these are supplementary angles. And in the multiplication, we have sine of B minus C. In the similar way, I can write this sine B as sine of C plus A. And sine C minus A is written over here in the multiplication, right? In the similar way, I can write sine of C as sine of A plus B, and sine of A minus B is written in there in the multiplication. Okay, so we know that sine of B plus C into sine of B minus C is sine square B minus sine square C. Please watch the previous page again. All these identities that I have been using over here have been written in the previous page. So just move the video back a little bit and watch all these identities that I have already explained in that page. Okay, so sine square B minus sine square C, that will be sine of B plus C into sine of B minus C. Sine C plus A into sine C minus A, that will be sine square C minus sine square A. And Sine of a plus b into sine of a minus b, that will be sine square a minus sine square b. Now as you can see, things are going to get cancelled out. Minus sine square c plus sine square c, sine square b minus sine square b minus sine square a plus sine square a. Everything gets cancelled out. It becomes 0. 0 into k will be what? 0. So that's our final answer for this question. Now moving ahead to the next question. A times cos of b minus c by 2 is equal to b plus c times sine of a by 2. We have to prove that. So either you can go from the left hand side or from the right hand side, whatever works for you. Suppose if I solve right hand side over here, it's easy to write sides in terms of angle. So I can simply write b as k sine b and c as k sine c from the sine rule again. In the multiplication, we have sine of a by 2. Okay. In the multiplication, we have sine of a by 2. Or you can go from the left hand side as well if you would like. Like you can write a as k sine a times, or instead of k, use 2r only. Because we know that a by sine a is equal to b by sine b, that is equal to c by sine c, and that is equal to 2r. So you can write side a as 2r times sine a, 2r sine a, and we have cos of b minus c whole divided by 2 in the multiplication. You can write side a as 2r sine a, and then we have this cos of this angle in the multiplication. Now you can write sine of a as sine of b plus c. Okay. And we have cos of b minus c by 2 in the multiplication over here. Alright. I've written a as 2r sine hai. 2r sine a can be written as sine of b plus c by 2. Now we need b plus c over here. Okay. So either we can apply that formula of 2 sine a cos b, or it would be better to go from the right hand side, because there will be lots of manipulation that we need to do now. Okay. What are those manipulation? I can give you an idea how to go forward in this question. That you can write sine of b 2 sine a cos b. Apply that formula of 2 sine a cos b. That will be sine of a plus b plus sine of a minus b. But as I told you, there will be a lot of manipulation involved if we go by that way. Okay. So see, going from simply left hand side or going from simply right hand side is going to get difficult in this question, because there will be lots of manipulation that we need to do. And this type of question has been asked in previous year a lot of times, that a cos b minus c by 2 is equal to what, and 4 options are given. One of the options are this. So how do we go forward in this question? So the idea to go forward in this question is that just simply change the question, that we are just looking for the value of b plus c by a. That's it. Just look at it in this way, that what are we looking for? We are looking for the value of b plus c divided by a, or a divided by b plus c. This is the value we are looking for. Okay. So b can be written as k sine b, side c can be written as k times sine c, side a can be written as k times sine a. K will get cancelled out in the numerator and denominator. Now in the numerator we will have sine b plus sine c, which is 2 sine b plus c by 2 into cos of b minus c by 2. In the denominator we have sine a, which is 2 sine of a by 2 into cos of a by 2. That will be sine a. Correct, everybody? Now have a look. This is the value for b plus c whole divided by a. b plus c whole divided by a, this is the value we are getting over here. Now, you can write b plus c as pi minus a. So here write b plus c as pi minus a. So we get sine of pi by 2 minus a by 2. What are we getting? 2 and 2 will get cancelled out. Here we are getting sine of pi by 2 minus a by 2, and sine of pi by 2 minus a by 2 is equal to what? Cos of a by 2. Right? Sine pi by 2 minus theta is equal to cos of theta. So here we are getting, see, pi minus a whole divided by 2 means pi by 2 minus a by 2. So sine of pi by 2 minus a by 2 will be cos of a by 2. So this thing this thing and this thing gets cancelled out. So what are we getting? We are getting this is equal to cos of b minus c by 2 upon sine of a by 2. This is the value for b plus c by a, and simply you cross multiply and you prove what you wanted to prove. So this is the idea we can go with in these type of questions so that it becomes very simple. It's very easy to prove, otherwise lots of manipulation will be involved. So here we can see that b plus c times sine of a by 2 is equal to a times cos of b minus c by 2, hence proved. Okay everybody. Now moving ahead. In the similar way, there is a similar question to in front of you. I am giving this question to you as a homework. You should try this question and let me give you an idea how to do this question. Simply try to find the value for b square minus c square upon a square. Get this thing. What is the value for this thing? Replace b with k sine b, c with k sine c, a with k sine a, and just have a look. Okay. Try this question. Let me know. Okay, this is what we have to prove. So get the value for b square minus c square by a square, and its value will come out to be sine of b minus c upon sine of a only. So try this question in this way. Okay, let's do this question. In triangle ABC, sine of b upon sine of a plus b is equal to what? You can write sine of a plus b as sine of c, right? So this is sine of b upon sine of c, and sine of b upon sine of c is equal to b by c. This is our answer for this question, which is option B. Simple. Moving ahead. Now we are going to be learning about cosine rule. So what is cosine rule? What does it say? So in any triangle, cos of angle A is equal to b square plus c square minus a square upon 2bc. Basically, if we have all the three sides of a triangle, we can find all the three angles. What are the values of angle A, angle B, angle C? Okay, if we have the sides of the triangle. So if the sides of the triangle are BCA, we have the value of cos of A as b square plus c square minus a square upon 2bc. The value of cos of B is equal to a square plus c square minus b square upon 2ac. See, in cos of B, we have minus b square. In the denominator, we have this. In cos of C, we have minus c square. And in the denominator, we have 2ab. So I think you can observe the pattern in this formula, and these formulas are very, very easy to remember, and we'll be using these formula whenever we have sides, we want to find angles. So in that scenario, or if we have two sides, suppose this is triangle ABC, this is side A, this is side B, side C. Suppose if I have the value of side A, side B and angle between them. Suppose if I have these three things are given, side A is given, side B is given, and angle between them, angle C is given. So we can easily find the value of the third side by using the formula of cosine C, that cosine C is equal to a square plus b square minus c square upon 2ab. So the only unknown over here is this c square term, which we can easily find by putting all these values in this formula. Easy. Moving ahead. Suppose side A is given equal to 2, side B is given is equal to 1 plus root 3, and angle C is given equal to 60 degrees. Then solve the triangle ABC. Basically find the rest of the things in this triangle. So we can apply the formula of cos C, that cos C is equal to a square plus b square minus c square upon 2ab to get the third side. Now angle C is 60 degrees, so cos of 60 degrees is 1 by 2. Right, the value of cos C will be 1 by 2. A square will be 4. B square is basically 1 plus root 3 square. 1 plus root 3 square is 4 plus 2 root 3. This is the square of 1 plus root 3, correct? Minus c square upon 2a. A is 2, b is 1 plus root 3. Okay. So this 2 will get cancelled out from both these sides. Just simply cross multiply this part to the left hand side. So we get 2 plus 2 root 3 in the left hand side. In the right hand side, we have 4 plus 4, 8. 8 plus 2 root 3 minus c square. So 2 root 3 term will get cancelled out. We get the value for c square as 6. So side C will be root 6. So we got the third side. Now we have to find the rest of the angle. We have to find angle A and angle B. So to find angle A and angle B, we can further apply cosine rule if you would like. That apply the value of cos of A. We have all the three sides. You can put the formula of cosine of A, right? We have side ABC. Cosine of A formula will work like a charm. But that will produce some calculation. So instead of using cosine of C formula, you can use sine formula to get the rest of the angles. So let me know what are the rest of the angles. So use sine rule, that A by sine A will be equal to B by sine B, that will be equal to C by sine C. Now what's the value for side A? The value of side A is 2. So 2 upon sine of angle A, which we don't know. The value of side B is 1 plus root 3. So 1 plus root 3 upon sine of angle B, which we also don't know. We need to find these two angles, is equal to C. C is root 6 upon sine of angle C, sine of 60 degree. So this thing we'll know. So sine 60 degree is root 3 by 2, correct? If you put the value for this as root 3 by 2, 2 is going to get in the multiplication and root 3 and root 6 will get cancelled out. We'll get 2 root 2. Okay. This is equal to 2 root 2, root 6 upon root 3 by 2. So we have 2 by sine A is equal to 2 root 2. So sine A will be equal to 1 by root 2. So from here we can get the angle A. From here we know that sine B, 1 plus root 3 upon sine B is equal to 2 root 2. So sine of B is equal to 1 plus root 3 upon 2 root 2. So from here we can say that yes, our angle A is going to be equal to 45 degree, right? And this angle is going to be 75 degree. Because the value of sine 75 degree is 1 plus root 3 by 2 root 2. Or if you have two of the angles, one of the angle is 60, other one is 45. So the third one is obviously going to be 75 degree angle, right? This is how you can go about in this question. If the sides of a triangle are 4, 5 and 6, then prove that its largest angle is twice its smallest angle. This is also one of the standard question. Hashtag standard question. If the sides of the triangle are 4, 5 and 6. Okay. Sides of the triangle are 4, 5 and 6. So let's say that this is angle alpha, this is angle beta, this is angle gamma. Can you tell me which angle is the smallest angle? The smallest angle is opposite to the smallest side. The largest angle is opposite to the largest side in a triangle, right? Recalling it, yeah, remember it. So opposite to 4, this angle alpha is going to be the smallest angle of the triangle, and this angle gamma is going to be the largest angle of this triangle. Correct? Now let's find these values. So we have to prove what? Then prove that its largest angle. We have to prove that gamma is equal to 2 times alpha. This is what we want to prove. Okay. To prove that gamma is the largest angle is twice the smallest angle. Okay. Now let's have a look. So first of all, let's find the value for cos of alpha. The value of cos alpha is going to be 6 square plus 5 square minus opposite side square. Okay, so 6 square plus 5 square minus 4 square upon 2 times 6 into 5. Upon 2 times 6 into 5. So its value comes out to be what? So we have 36. Okay. And this will be 9, 5 square minus 4 square, that will be 9. So 36 plus 9, that will be 45. So we have 45 in the numerator. We have 2 into 6 into 5 in the denominator. Okay. 5 9s are 45, 3 3s are 9, 3 2s are 6. So we have 3 by 4. This is the value of cos alpha. So cos alpha came out to be 3 by 4. Now let's talk about cos of angle gamma. Okay. So let's talk about cos gamma. So cos gamma is going to be 4 square plus 5 square minus 6 square. 4 square plus 5 square minus 6 square upon 2 times 4 into 5. This will be cos of gamma angle. So let's find the value for this. So 4 square is 16. This will be minus 11. 5 square minus 6 square, 16 minus 11, that will be 5. So 5 in the numerator. In the denominator, we have 2 into 4 into 5. So the value of cos gamma, 5 and 5 will get cancelled out, will get 1 by 8. So this is the value for cos gamma as 1 by 8. We have to prove that gamma is 2 times the angle alpha. So if this is cos alpha, I can for sure say that our cos 2 alpha will be equal to what? Cos 2 alpha is 2 cos square alpha minus 1. 2 cos square alpha minus 1. This is the value for cos of 2 alpha. 2 cos square alpha minus 1. Now we have the value of cos alpha is 3 by 4. So 2 times 3 by 4 square minus 1. Right? Cos alpha is 3 by 4. So we have over here 3 3s are 9, 9 2s are, okay. In the denominator we have 16. 2 by 16 in the denominator will have 8. 9 by 8 minus 1. So we have this 9 by 8 minus 1 which will be equal to 1 by 8. So yes everybody, we got the value for cos 2 alpha as 1 by 8. Cos 2 alpha as 1 by 8. Right. So, and this is equal to cos gamma. The value of cos gamma is also 1 by 8. So here, from here we can say that cos 2 alpha and cos gamma are equal to each other. So 2 alpha and gamma will be equal to each other. So from here we can directly compare the angle that 2 alpha is going to be equal to gamma. Okay, these two angles are going to be same. Okay, simple. So that's our answer for this question. We have a similar question to this. If in a triangle ABC, B plus C by 11 is equal to C plus A by 12 is equal to A plus B by 13, then prove that cos A by 7 is equal to cos B by 19 is equal to cos C by 25. So let me give you an idea on about how to solve this question. First of all, consider this is equal to some constant lambda, let's say. That B plus C by 11, C plus A by 12, A plus B by 13. Let's say this is equal to some lambda. So from here I can say the value of B plus C will be equal to 11 times lambda. 11 times lambda. The value of C plus A is equal to 12 times lambda. The value of A plus B is going to be 13 times lambda. So if you add all of these, in the left hand side we get 2 times A plus B plus C. In the right hand side we have 11 plus 12 plus 13. Okay, so that will be 36 lambda, right? So we have the value of A plus B plus C as 18 lambda. Now, get the values of A, B, C in terms of lambda. Okay, so we already have B plus C as 11 lambda. So if you simply put the value for B plus C as 11 lambda over here, we are getting the value of A. That A will be equal to what? A plus 11 lambda is equal to 18 lambda. So A is equal to 7 lambda. In the similar way, we have the value of C plus A as 12 lambda. So if you put the value for C plus A as 12 lambda, the value of B will be 6 lambda. In the similar way, we have the value of A plus B as 13 lambda. So if A plus B is 13 lambda, so 18 minus 13, that will be 5 lambda. Okay, so that will be the value of C. As you can see that their sum should be 18 lambda. Yes, it is. 7 or 6 plus 5. Yes, this is 18 lambda. So first of all, we got the values of A, B, C in terms of lambda. Now we can get the value of cos A, cos B, cos C by simply applying the formula that the value of cos A is equal to B square plus C square minus A square upon 2BC. So the value of B square, that will be 36 lambda square, C square, that will be 25 lambda square minus A square is 49 lambda square divided by 2 times B into C, 6 lambda into 5 lambda. So lambda square will get cancelled out in the numerator and denominator. As you can see, in the denominator we have lambda square, in the numerator we also have the same thing. So from here we get the value of cos A. In the similar way we get the value of cos B and the value of cos C. Once we have all these three values, we can easily prove that, right? Just simply put the value of cos A over here, cos B over here, cos C over here, and we will get what we wanted to prove. Okay, simple. So cosine rule is also very, very handy, very, very useful. So you can complete the rest of the question over here. And I'm giving to you a similar type of question for your homework. Let me know what should be your answer. We are looking for angle A. Just simplify this relation and you will form the formula of cosine of A. So let me know that which option is correct. Okay, write your answer in the comment section and we'll see that how many of you have given the right answer for this question. So that's it everyone for our today's session. In this session we have covered two very, very important topics, which is sine rule and cosine rule. So we are going to continue later on. Thank you everyone for being a part of this session. See you in the next one. Till then, this is your maths teacher Kunal Mankar signing off. Tata, bye bye, have a great day.